Thank you. Hey everyone, thank you so much for having me. And I realize that talking about AI and machine learning is some pretty hefty topics for like 20 minutes before happy hour. So I will do my best to keep it light and accessible. And I will also be there if you have any questions or you want to chat about any of this. So quickly, just a little bit more about me. I've been at Google for about 4.5 years, and I'm a UX researcher. And I've had the opportunity to work on a number of really exciting products. So I've done research on Gmail and some experimental AI-driven productivity tools for G Suite. I've worked on ads forecasting tools as well. And currently, I'm a UX researcher on Stadia, which is Google's new cloud streaming gaming platform launching next month. Things are busy. But throughout my last 2 years at Google, I've used my 20% time to do some work with Google's People plus AI Research Initiative, also known as PAIR. And that is the work I'm going to talk with you a lot about today. So before I talk about what human-centered AI really means and what it means for you and conversions and revenue, I'd like to define a few key terms about machine learning just to make sure we're all on the same page. So at its core, machine learning is the science of helping computers discover patterns and relationships in data. And the way that many of you probably encounter machine learning in your day-to-day is through these dynamic personalization experiences. For example, Spotify's Discover Weekly or Netflix content recommendations algorithm. But of course, machine learning is also driving some really exciting future innovations that Google and other companies are working on. So self-driving cars, medical diagnosis technologies, the possibilities are endless. And machine learning and AI have a lot of different flavors to them. But one of the most common methods used to create machine learning algorithms is called supervised learning. And so to illustrate this, I'd like you to imagine that you are creating an algorithm to identify pictures of dogs. So if you wanted to do this by hand, you would have to identify all of the mutually exclusive criteria that make something look like a dog versus not a dog. And that might seem easy at first, but then when you start thinking about how different a Chihuahua looks from a Great Dane and how similar a cat might look to a Pomeranian, suddenly you're like, how do I teach the computer which is which? So an alternative way of doing this is machine learning. So what you might do is you would feed in a structured labeled data set of images labeled dog and not dog, for example. And you would use this training data set to then train an algorithm to properly figure out on its own what the difference is between a dog and not a dog. And once it can do that reliably, you would then be able to give it a new image that it hasn't seen, something that was not part of the original training set. And if your AI is successful, it will be able to then classify this new image properly. So in this case, calling it a dog. And often when we talk about machine learning, we're really focused on the technical aspects of this and on metrics like how accurate is this algorithm? Is it predicting dog versus not dog with 80% accuracy, with 90% accuracy? What are the levers that we can tweak in this in-between step here to make it better? But I'd like to challenge you all today to take a step back and think more broadly about how human perception drives virtually every aspect of machine learning. So what do I mean by that? Here's an abstraction of what I just showed you about how supervised learning works. So training data are collected and labeled, models are built, trained, and evaluated, and predictions are generated. And it is we, the people, the humans, who are choosing the data sources. It's not magic, and it is we, the humans, that determine evaluation metrics and success. It's us that decide, is it 80%? Is that good enough of a prediction confidence for my dog algorithm, or does it need to be 99%? That's up to us. And of course, we are the ones that get affected by the results. We are the ones who have to deal with errors made by machine learning, with bad predictions, and it is really a lot of humans involved in this magic that can be machine learning. So I'd like you to consider this experience, which hopefully is familiar to a lot of you. So imagine that you are running targeted ads using a machine learning algorithm. And this machine learning algorithm is using a variety of factors to predict with relatively high confidence how likely a given user is to respond or to be a potential customer of this leather jacket. So maybe it's taking factors into account like inferred demographics of who this user is, websites that user has visited in the past, maybe even items that they viewed or put in their shopping cart from particular websites. And so you're like, all right, well, we got this really smart machine learning driven targeting. So now what messages and calls to action do we want to put in our creative to try to drive the most conversions? So you might have this discussion among yourselves and your team of, okay, well, do we reveal the smarts behind this targeting and tell them like, hey, you've got this item open in another tab in your browser. Like, why don't you go back there and buy it? Or do we do something more generic? Or do we do something different altogether? Like, what's the right choice here? The right choice may depend on a lot of factors that you might not be thinking about if you're not taking a really targeted human-centered design approach. So for example, consider user expertise. Is the person viewing this ad likely to be somebody who understands how ad targeting technology works? Do they know what cookies mean? Do they know how ad pixels target them and like, keep track of items that they viewed? If so, then they might find the ad on the left really smart and helpful. It might not just drive them to click, it might also raise their perception of the brand associated with this ad. However, if the user is not an expert and doesn't really understand how these sort of algorithmic targeting works, they might find the ad on the left really creepy and scary. Like, how do you know that I was looking at this? I thought that was on my phone, and now I'm on my computer. How does that even work? And they might not just be unlikely to click, they may be likely to install an ad blocker or to feel really unfavorably about this brand moving forward. Another thing to consider is what assumptions is the model making and what are the consequences if it gets it wrong. So maybe I've already purchased this item. And so that could be that I don't really care. I'm like, okay, well, that's a little dumb. I've already purchased this. Or it could make me feel, again, really unfavorably about this brand because I'm like, well, how does it not know that I already purchased this item? Why is it showing it to me again? So there's all these considerations we need to take into account. So how should you think of this problem? What is the right answer? Which of these is better? The People plus AI Research, or PAIR team, has put together a lot of resources to help you think through exact conundrums and problems like this. And most recently, we released a resource called the People plus AI Guidebook. And the People plus AI Guidebook, it has a lot of resources. It lays out in detail all of the factors that you need to consider, like the ones I just mentioned in regards to the ad. The guidebook does not offer universal solutions and won't just give you the right answer to that problem that we just discussed, but it will provide examples and frameworks to help you and your team have the right conversations and make sure that you're considering all the important factors in play and that you're avoiding common pitfalls in your decision making. The People plus AI Guidebook is the work of over 100 contributors from dozens of product areas across Google and Alphabet. So we had contributors, everybody from Waymo to Photos to Medical Brain to Gmail and to ads. And the way to think about the guidebook is that it's a toolkit that you can use to make sure all of the time and resources that you pour into AI is actually going to result in something that's usable and useful for your users and that drives revenue for you. So in the remainder of my talk, I'm going to give you a very high-level introduction to the guidebook and talk to you about how you can use it to address your business needs. The guidebook has 6 chapters that address everything from defining your users' needs and your success criteria to figuring out how to recover from errors and failure and to figuring out how to best collect feedback on your AI. So the first chapter is all about how to identify whether or not AI even adds unique value to your product. Is it even worth all of the time and expense of integrating AI or machine learning into your particular product? So the way to illustrate the key concepts covered in this chapter is I'd like you to imagine that you're a product manager in retail and you're considering whether or not to use AI to automate your returns process. So this chapter would guide you on how you could approach conducting user research to identify the unique opportunities of where a fully automated solution could add value versus where you might want to use AI to augment the work that your human employees are already doing. It would also help you choose the right success metric that the AI would optimize for, which is called the objective function. So for example, an AI system that's built to optimize for cost savings might function very differently than a product using AI that's built to optimize for some sort of metric around customer success. So that's the first chapter on user needs and defining success. And throughout this chapter and all of the chapters of the guidebook are actionable insights. So these distilled boxes that call out the key questions that you and your team should discuss as you're making decisions with AI. The next chapter is about translating your users' needs into data. So once you've decided that AI will indeed add unique value to your product, the next step is figuring out what is that set of labeled, structured training data, like those dog images we talked about. What is that data set for you? And how do you get it? And how do you know that it's all the right data you need to train the system that will lead to the success that you want? So to illustrate the key concepts covered in this chapter, I'd like you to imagine that you're a designer and you're working for a large hotel or resort chain. And if you have a great idea of how you want the AI to make personalized recommendations to guests during their stay, but you don't know how to have the right conversation with your data scientist to figure out what is the data set that you need to even make your idea come to life. So this chapter would help you work backwards from the experience you want to provide to the data that you need to create that experience. It would also talk you through how to create any data labeling tasks in a way that reduces bias to make sure you get high quality data. So what I mean by data labeling tasks is if you think back to that first example of the images of dogs, somebody had to put those labels on there, and you better make sure they know what a dog is versus a bird is. And that might seem a little bit simple, but when you're doing something like, is this recommendation good or bad? And that's the thing you're wanting to feed in. Or would you call this experience a spa experience or a wellness experience or both? What's the right label to attach? That's where it gets a little bit fuzzier, and you have to be really thoughtful about who's labeling your data and how those tasks are being done. In this chapter and in all the chapters, we also recommend a lot of tools that you can use to help you get high quality data. The PAIR team has built a tool called Facets that helps you see in a visual way at a glance any weird anomalies in your data so you can catch them before they get fed into your algorithm and start causing problems. We also have a tool called a what if tool that helps you figure out what are the trade-offs of optimizing for one thing versus another thing within your AI algorithm. And we'll talk a little bit more about this in a bit. The next chapter is on mental models, and the way of thinking about a mental model is really understanding what is your user's point of view, what is their current level of understanding that they're bringing to the experience, and how do you need to design around that in a way that accommodates them and sort of meets them where they are. So to illustrate the key concepts covered in this chapter, imagine you're a marketing or a content strategist lead, and you are considering how to brand and introduce a new AI-driven feature to your customers. So do you use the term machine learning in this marketing? Do you give it a human name? Do you ignore the tech completely? Do you give a full explanation of all of the technology that's behind the scenes? What is the right approach? This chapter would guide you on the best practices for identifying the existing mental models that users have when coming to your product and how to test and iterate on your message through user research to get to the best choice. For example, if you do decide to give your AI product a human name, you need to be aware of all of the expectations a user might be bringing to that experience, like, well, then it should be able to do this following list of things that any human should be able to do. If that's not true for your product, maybe that's not the right choice. This chapter would also walk you through all of the user needs and trade-offs you need to consider when making a decision of how to approach that branding. And throughout this chapter and all the chapters, we have an aggregated list of research. So we link to a bunch of academic research as well as other industry publications that we use to make our best practices and recommendations and guidelines that you'll find in the guidebook. And you might think that once you have built a working AI that makes predictions with high confidence, and you've figured out the right branding based on the mental models your users are bringing to the table, and you've got all the right data, and you've done all these things, that your hard work is over. But that's not true, because if you don't explain the product to the user properly, it could be ignored or misused. So to illustrate the key concepts covered in this chapter, imagine you're an executive at a consulting services company, and you've built some AI-driven tools for your clients. And you want to make sure that they're actually going to engage and use these tools. And you also want to make sure that they adequately understand the capabilities and limitations of the system. This chapter would guide you on how to properly define and calibrate trust for your customers and your system. You might be thinking, well, don't I just want them to trust what I've built? Obviously, like, more trust is always better. But that's not necessarily the case. Because AI is inherently a predictive system, it's never going to be 100%. And so you want to make sure that you are giving the right information to your users so that they know when they can trust the prediction or recommendation completely versus when they should double check it with their own, bringing their own knowledge to the table. You will also find in this chapter examples of ways that you can illustrate AI prediction confidence. So what I mean by that is you may have seen, for example, in something like Google Maps, like recommended for you, 75% match. So that's one way of illustrating confidence. That way has trade-offs. There are lots of other ways of illustrating the confidence of your predictions as well. Whether or not to show any illustration of confidence and then which one to choose is a really tricky process that needs a lot of thought. And in the guidebook, we teach you how to think about that and how to think about the trade-offs of all of the different ways of showing model confidence. As I mentioned, there are lots of illustrations of kind of do's and don'ts or aim fors and avoids throughout the guidebook, not just in this chapter, that actually show you here's what a UI looks like that follows best practices, and here's what it looks like when it doesn't follow best practices. And you also want to make sure when you're building AI that you are learning from your users. So you're going to launch an AI-driven product or service into the world. It's going to be making predictions and recommendations, and then you want to make sure it gets better over time. It can't get better over time unless it's actually actively taking in feedback and adjusting itself accordingly. So to illustrate how to think about the key concepts covered in this chapter, imagine you're a UX researcher for a financial services company, and you want to make sure that the AI-driven recommendation system guiding customers' investment strategies is working well and improving over time. So this chapter would guide you on how to triangulate between usage data collected in product. So for example, how many people are actually clicking yes, accept on the recommendations. That's one signal. It would also teach you how to combine that signal with more subjective data collected from users. For example, surveys, feedback, and then how to take both of those signals of data and structure it and morph it into something that, in collaboration with your software developers and ML scientists, could actually then be fed back into the system to make it better. Throughout this chapter and all of the chapters in the guidebook, we have some key vocabulary terms as well to help you get familiar with the language of machine learning and have more effective conversations with your more technical counterparts who are actually building these AI systems. And lastly, in the guidebook, we talk about errors and graceful failure. So as I mentioned, AI is an inherently predictive system, and so it will make wrong predictions. What do you do with that? In the guidebook, we encourage you to think of these not as scary things to be avoided, but opportunities to get feedback and to be transparent to the user about how the system works. So to illustrate these key concepts, imagine you're a software developer working on a food delivery app, and the app is going to predict wait times for delivery from a given restaurant, and you're trying to determine the thresholds for when to show the customer an estimate versus when to show estimate unavailable. So this chapter would give you guidance on how to collaborate between marketing and UX design and research to figure out the criteria for when a user will judge an estimated wait time as helpful versus wrong versus something in between. It would also help you ensure that your system is learning from its mistakes and bad predictions. So let's say you say, hey, wait time is about 20 minutes, but then 5 seconds later you realize that was inaccurate, and so you update it to 40 minutes, and the user cancels their order. Well, that was a mistake. Maybe you should have communicated it differently, and the machine should be able to learn from that. In this chapter and in every chapter, we have worksheets. And this is one of the most powerful tools that we have in the guidebook. And so if you want to sit down with your cross-functional stakeholders and block out a couple hours and work through some of these key decisions and design challenges together, we have these tools in the guidebook to help you do that as a team. I just threw a ton of information at you, so I would like to close the talk by walking through a brief example of how the Google Flights team put some of these best practices and frameworks from the guidebook into practice when designing a new feature called price prediction. So within Google Flights, there is first of all, who's used Google Flights in the last, oh, wonderful. Who's seen this feature? Price prediction. All right, well, take a look next time you go. So price prediction is a machine learning driven feature that tells you whether or not the prices that you're looking at in Google Flights are typical for your trip or whether they're likely to go up or down, and whether they're like a little high. So for example, you might look at this and then help you make the decision of, well, prices are a little bit high right now, and it's telling me that the best time to buy might be in another week or two, so let me wait and come back. So how did the team get to this very helpful feature? When they first were considering user needs and defining success, they had a big question come up about, well, we have this price prediction capability, but we're not really sure how to tune it properly. So if we tune it in one direction, then it might make a lot of false positive predictions. And if we tune it in another direction, it might make some false negatives. And we're not really sure, like nothing can be perfect. So like, where do we err? And so through user research, they were able to define a confusion matrix in a very user-centered way. So what I mean by this is that if the AI predicts that the price will go up, and the price does indeed go up in the future, that's a good thing, right? No one's going to argue about that. Great. If it predicts it will not go up, and it indeed does not go up, also great. But what happens if the AI predicts that in 2 weeks the flight price will go up, but then the user checks back 2 weeks later and it looks like the price is the same? Nothing really bad happened there. Like maybe they could have bought a little early and got an even better seat, but like not a terrible experience. However, if the AI predicts that, oh, don't worry, the flight price is not going to change, you can wait till you get paid, come back in 2 weeks, no problem, you'll get the same price, but it goes up, that's really bad, right? Like the user experience will be terrible. So through a lot of user research and through following some best practices of how to think through these problems, the team was able to identify what they wanted to optimize for and train the AI accordingly. Next, the team did a lot of great thinking around how to align user needs to AI outputs and doing that work backwards I talked about of how to figure out what data they actually needed. So they knew that ultimately what the user wanted to do when they came to the tool was make the decision of when do I need to book this flight? Do I need to book it now? Should I wait? So what the AI needed to produce was two things. One, a contextualized representation of what is the current price. Is it good or bad compared to historical data? And then second, a price prediction. Do we think it's going to go up or down in the future? So then to make those AI outputs, we need certain data. And so they had to think about what are all of the data inputs that we would need to then create those outputs that can then fit the user's needs. So they ended up with this large structured data set with all of the different components that they knew they needed to, with confidence, then give the user those two AI outputs to help them make a decision. And the last example of how the flights team put this together is the framework they created for communicating these predictions to people. So the flights team did a lot of research to understand their users. And as you know, everybody flies. Regardless of your income or education level, maybe you fly more or less frequently, but they knew that the way the system communicated itself needed to be universally understandable. So they came up through a lot of testing and iteration. They came up with a framework for describing describing the AI predictions to people and helping them make a decision. So if the prices are currently high, it probably is not going to nudge you one way or another. But if it's medium or low, they will try to encourage you, depending on how confident the system is, to make a decision and go ahead and book. And again, the end result is this, and it's being highly successful in production. So that's the AI Guidebook. I encourage all of you to check it out, and in a much more slow and easy to digest format than the wealth of information I just poured on you. Take your time and go through it, and I encourage you to use the resources to work through it as a team to try to make really good decisions about the AI-driven products you're using. The guidebook can be found at design.google/AI Guidebook, and here's my contact information if you're interested. And again, I'll be at happy hour to chat. Thank you so much.